Okay, so we've talked about ways to find out how many possibilities that there are for a certain thing to happen. Now what we're going to do is talk about probability, which is how likely something is to happen. So the problem set is problems 1 through 12 on page 477. Make sure to do those before trying the quiz. This page just has a lot of vocabulary on it. Please take a look at it. You might actually want to pause this little recording. Because I've already done this recording once and found that if I talk about it, we won't have enough time to do the examples. So, if you would please, take a moment to read them through. Pause it. Okay, hopefully you did. So, probability. Probability of event is how likely it is to happen. We express probability as a number between 0 and 1 or as a percent. Remember that decimals can be written as percents, so sometimes we talk about it in percent form instead. To kind of give you an idea of what it means for something to have a certain value, a probability of 0 means that something is absolutely impossible. So for example, the probability that I turn into a chicken is 0 or 0%. It's not going to happen, it's not possible. In contrast, the probability of 1 means that it is guaranteed to happen. It has to happen. So the probability that I'm going to have a nose 3 seconds from now is 1, or 100%, because 3 seconds from now, nothing will have happened in that time to deprive me of my nose. Now, for notation, we say P of A. So the probability of the event A happening is the number of ways to get A divided by the total possible outcomes. Another way to look at this or to express this is that P of A, or the probability of A happening, is the number of events that give me A divided by the sample space. So in every case, it's always how many ways can I get what I want divided by the total possible things that could happen. So here's one example, and I've given some guidance here as far as things to think about. What is the probability that I will get a cat's eye marble out of a bag that contains 7 cat's eyes, 10 swirls, and 3 solid black marbles? I've drawn a picture to kind of help you visualize it a little bit, I hope. The brown ones would be what my best attempt at a cat's eye marble. So what you want to ask yourself is there more than one step here? Remember, we talked about that before. Is there more than one step? Is there more than one decision to make? No, there's only one, right? We're just pulling out one marble. So anything we're doing, we'll just be adding things up. And does order matter? No. Since we're just picking out one number, there is no order. There's no issue there. So we want to know what the sample space is. The sample space would be all of the marbles, right? Because we are going to pick one out of all these marbles. There are a total of 20 marbles if you count them. So the sample space is 20. How many ways can I get the desired event? Well, okay, I have how many cat's eye marbles? There are 7 here. So that means that there are 7 different ways of getting a cat's eye marble, because I could pick any one of those 7. So the probability of getting a cat's eye would be the number of ways to get a cat's eye, which is 7, divided by the total possible outcomes, which is 20. I could pick any one of those 20 marbles. So this is 0.35, which is the same thing as saying that it's 35%. So there is a 35% chance that I am going to pull out a cat's eye marble. Here's another one. Gina is throwing 2 dice. She wins if she rolls less than 5. What is the probability that she will win? So, does order matter? Yes, in a sense, it does. In this case, oh, and I wrote yes there already. Yes, it does, because the 2 dice are independent of each other. So they are distinct, they are different, they work separately, so yes, order does matter, which means that we're going to be looking at multiplication. So yes, order matters, yes, there is more than one step, because I have 2 dice, 1, 2. So what is the sample space? 6 times 6 is the sample space, or 36. You could, of course, also itemize it all out and see how many different rolls you could possibly have. That would take a lot more time, but that's why we want to talk about, things like, is there more than one step? Yes, that's why we would multiply them. Does order matter? Yes, they are distinct, so we do want all of the possible options there. How many ways can she get the desired event? Well, let's think about that. We could look at this and say, well, I'm going to show you actually some work I already did to kind of prep and cut down on the time here. If you take a look at this, yes, order matters. The sample space, like we said, is 36. The total, all of the sums that we could possibly get are 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. For each of these, I actually worked out how many different ways I could get each one. There is one way to get a 2, because you have to have snake eyes for that. There are 2 ways to get a 3. You could get a 1 and a 2, or a 2 and a 1. There are 3 ways to get a 4, because you have a 2 and a 2, or you could have a 3 and a 1, or a 1 and a 3. So what I've done is already itemized out, or separated out, how many different ways I can get each of these things. For a 7, for example, there are 6 different ways. The 7 is actually the most likely roll when you're rolling 2 dice. So in case you ever wondered which one is the best one to pick, always pick 7. So if I add all these up, you'll notice that if I add up all the different possible ways I can get the sums, I still get 36. So how many ways can I get the desired event? The desired event is less than 5. Less than 5 is 1, 2, and 3. There was 1 way to get a 2, 2 ways to get a 3, 3 ways to get a 4. A sum of 2, 3, or 4 are all less than 5, so that's how many ways to get the desired event, 6. So the probability of getting less than 6 is 6, because that was how many ways I could get the desired event, divided by 36, which was the total different number of ways I could get a sum at all, total number of rolls I could get, which is 1 out of 6, or 0.167, or 16.7%. So just a brief comment about complementary probability. If 2 events are complete opposites, then they are complementary events. So for example, getting a red marble versus getting a marble that is not red. You only have 2 options there. Either you get a red one or you don't get a red one. So you could say that the probability of getting a red one plus the probability of not getting a red one is going to be equal to 1. Because if you're picking marbles at all, you're going to either get a red one or not a red one, so basically you're saying that the probability that you get a marble at all is guaranteed, that it is 1. So here's an example where that might be helpful. Kiva is in the pasta aisle of the grocery store. There are 4 types of whole wheat pasta, 3 types of enriched pasta, and 8 types of regular pasta. If he chooses a random pasta, what is the probability that it will not be regular pasta? So how might we use that complementary probability idea? We want to know the probability that it will not be regular pasta, but that means we could also figure that out by doing the probability that it will be regular pasta. So let's say that we want the probability of getting a regular pasta. Well, there were how many? 8 types of regular pasta. There are a total 4 plus 3 plus 8, which is 15 total different pastas that he could buy, which is, if I do 8 divided by 15, this is 0.5333333333, and on and on and on, which is approximately 0.53. So we can say that the probability of getting regular pasta plus the probability of not getting regular pasta has to be equal to 1. So that means that the probability of getting pasta, which is 0.53, plus this unknown probability of not getting a regular pasta is equal to 1. So I can subtract the 0.53 from both sides. And I would get then that x, the unknown probability, is equal to 0.47. Correct? I hope. Let's just double check that with my calculator. Although I'm pretty confident that's correct. Yes, that's correct. Okay. So the probability of not getting regular pasta is 47%. So that's an example of how you might decide to use the complementary probability instead of going directly excuse me, for a probability. There are problems that are much more complicated than this one, where it's much more helpful, much easier to do it this way. Okay, so hopefully this will shed some light on the probability lesson for you. I'm going to put this vocabulary up here again, since I do have a little extra time this time, and just remind you to make sure that you always read and pay attention to vocabulary so you can talk about things intelligently and express yourself well. Alright, the ones that we used mostly here was sample space, was the total number of outcomes. The event or the result is what actually happens. The event is something that might happen, or a specific value. So we did, we saw some events. Events would be like getting a cat's eye marble, getting a swirl marble. Those would be events. Usually we talk about it in the context of a desired event. Okay, so once more, here is the problem set assignment. It's problems 1 through 12 on page 477 of the reference guide. Keep asking yourself good questions like, does order matter? And understand that sometimes you can expand things out a bit to help you out. Okay? And do let me know if you have any questions.